Number 6 from your homework last night involves the type of triangle we didn't study yesterday, so my bad for putting it on the assignment. What we're looking at here for given information is we have two sides and the angle. So side-side angle is the scenario. And when we have side-side angle, it's going to be law of sines case 2. When we look at law of sines case 2, if you look at what we know, if we have side-side angle, is we know that these two sides, this side and this angle, correspond to one another. They're in the same piece, basically. And then this side and that angle go with each other. And I'm just going to call this side H over here, little h. So that angle and that side correspond to one another. So if I'm writing up the law of sines with all this information, it's going to look like this. It's going to be 15 over sine of j equals 11 over sine of 31 equals little h over sine of big H. With a side-side angle set up, that's what the law of sines looks like for what I know at this moment in time. And even though I don't know little h or big H, if I look at these two fractions here, the sine of 31, according to my calculator, is 0.5150. So these two fractions here, ignoring that one over there, if I cross multiply, is going to get me a workable expression that has one variable in it. So if I do that cross multiplication, this product gets me 11 sine of j, and this product, 15 times 5150, is 7.725. Now this is an occurrence in this problem that's going to happen. What we don't know is j. It's attached to the sine function, so I want to get this by itself before I worry about the j inside the sine function. So I'm going to divide by 11. So divide by 11 here, divide by 11 here. So 7.725 divided by 11, my calculator says is 0.7023. Now, as long as that number, 0.7023, is between -1 and +1, your calculator can evaluate it. Even more specifically, it's going to be between 0 and +1 if it's doable for these problems, because you're not going to get negative numbers in these problems. So it should be somewhere between 0 and 1. If it's bigger than 1, the triangle's not possible. Okay, and that's what you'd say. So if this said sine of j is equal to 1.17, your calculator will say domain error, it's not a possible triangle. So, but again, this one is possible because it's less than 1. So what I'm going to type in my calculator to find j is the inverse sine. And for that one, I'm going to bring the calculator up on the board so you can look what it looks like. So for me, the sine, cosine, tangent buttons are here. Above the sine is sine -1, above cosine, cosine -1, above tangent, tangent -1. So I want sine -1 of 0.7023. The function on the calculator says, I want to know what angle makes that sine value. That's what sine -1 does for me. So if I know sine equals anything, then inverse sine of that anything equals the angle that made it. If this said tangent of j equals that, then an inverse tangent would make the angle. So that's what we're doing here to find the angle. On the gray calculators, when you bring up your trig menu like normal, you hit second pi. It has sine, cosine, tangent on the screen. If you keep arrowing down, then sine -1, cosine -1, tangent -1 are below those. All right? But again, it says sine equals, so I'm doing sine -1 equals. It comes out to a 44.61 degree angle. Now, let me just give you some information about trigonometry, specifically inverse sine. This calculator is programmed to find the inverse sine of an angle that's an acute measure. between 0 and 90, that's what it does. That's how it's programmed, right? Every acute angle has an obtuse angle that has the same sine values. They just do. So to step 2 in that process of case 2 is I'm going to do 180 minus the angle I just found. So if I do 180 minus the previous answer, 135.39 degrees. So I'm going to write J equals 135.39. Now, just to verify this angle makes that sine value. And I'm telling you, this angle has the same sine value. So if I type in sine of that exact number there, 135.3881742. There's more decimals that the calculator doesn't display, but if I do that, I'm going to get, notice, 0.7023. Right? So again, the calculator's programmed only to give the acute answer. It's my job to find the obtuse answer. And all I got to do is whenever I do this step here, and it's side-to-side angle, and I've gotten to this point where I found the angle, it's acute, 180 minus this answer gets me this other answer. Okay? I keep doing both answer sets until it fails. There's either 2 sets of answers or there isn't, but I don't know it there isn't until it fails. Failure would be a negative angle. If we're trying to find h, and this obtuse measure causes h to become negative, then it fails, we throw it out. All right, so at this point, I'm still supposed to find h and little h, big H, little h. So big H equals something, and then little h equals something. And again, as long as we go along with both possibilities, J being the acute angle, J being the obtuse angle, as long as h comes out to a positive angle, I'm going to keep going with 2 sets of answers. If this h becomes a negative angle because of that angle measure, then we say that's not possible, we can't do it. All right, so I'm going to start with the 44.61, this one. I'm trying to find h. So I know that measure of angle h plus 31 degrees plus 44.61 degrees is supposed to equal 180 degrees. And if J is this acute angle, G is this acute angle, right? So those 2 angles added together plus H should equal 180. So the measure of angle H plus 75.61 equals 180. So we subtract. And that's going to be 114.39 degrees. If instead J is the 135.39 degree angle, G is still 31 degrees, and I want to find out what H equals, the measure of angle H is equal to, plus 31 plus 135.39 is equal to 180 degrees. So I add those up, measure of angle H plus 166.39 degrees equals 180. We chop this off and move it over, minus, oh, sorry, yep, 166.39. That's going to give me 0.61, that's 13.61 degrees. So once the angles happen, and once both sets of angles are possible, again, 3 angles that add up to 180 in the same triangle with all the same criteria, right? Sine of this equals 0.7023, sine of this equals 0.7023. So J is an angle that has a sine value of 0.7023. Both of these angles do that trick. And then adding to 180, 31 plus this makes 180. 31 plus this makes 180. So both of these setups are possible triangles for this scenario. Final step is to find out what little h equals. And we go back up to our main proportion here. Find little h. I'm going to go right here. And I've got 2 different answers for big H, this answer and this answer. So I'm going to perform this proportion twice, once with h equals 114.39, one with h equals 13.61 to find a little h for both scenarios. So for this one, I'm going to get 11 over 0.5150 equals little h over sine of 114.39. That's going to find this answer. My calculator says sine of 114.39 is 0.9108. And it's just like we saw yesterday, just got a basic proportion, got to cross multiply. We're going to have some 4 decimal place ugly equation, but it is what it is. So 0.5150 h equals 11 times 0.9108, so 10.0188, divide by 0.5150, and my calculus says h equals 19.45. Okay. The other angle h, again I'm going back here, 11 over 0.5150. Try writing that again. 0.5150 equals little h over sine of the other angle h, which is 13.61 degrees. My calculus says sine of 13.61 degrees is 0.2353. So cross multiply 0.5150h equals 11 times 2353, 2.5883. Divide both sides by 0.5150. .5883 divided by 0.5150 is 5.03. So both sets of answers are possible. Okay. Couple places that this type of setup could fail. Anytime you hit failure, you throw out the possibility of a triangle existing. All right. First place is if it says sine equals something bigger than 1, can't even do it at all. Not possible. Okay, so at that point, if this says sine of j is equal to 1.17, you would stop, you'd say no triangle possible, you're done, the end. Second place it can fail, you're going to get an answer if this is less than 1. There's going to be a 2's answer that matches it. Just 180 minus this makes that. All right. And then when you go to find h, if h over here becomes a negative number, let's say this was 155. 155 and 31 is 186. All of a sudden, h would equal -6. Negative angles aren't possible in triangles. So at that point, this triangle fails, this one still passes, so you finish up just this one triangle. So when you have side-side angle, there's either 0 triangles possible, 1 triangle possible, or 2 triangles possible. And again, go with the assumption there's 2 until that second one fails. All right. Go with the assumption there's an answer until it says sine equals something bigger than 1, then you say it's not possible. All right. So that's how you handle a side-side angle. Again, more challenging, but again, the math itself isn't terribly difficult. There's just a bunch going on. You know, I mean, you got to deal with 2 sets of answers, so do the work again. Do the work again. All right, so the work itself isn't terribly difficult, just that possibility of 2 answers. And again, the magic angle, the one that the calculator does not give you, is this angle right here, and you simply have to do 180 minus this answer. Whatever that is, 180 minus that makes that. Again, that's just how sine works. There's an answer over here, there's an answer over here. A cube of 2, so there are 2 answers. So the calculator's program only gives you the acute answer. It never gives you the obtuse answer. So you have to make the obtuse answer up. Again, 180 minus that makes that every time.